Welcome to the session. Greeting of the day. In today's class, we are going to talk about data acquisition systems. In previous classes, we have seen the various signal conditioning units and how the various sensors are connected with the system. It means the analog to digital, digital to analog. How this data are changed from one form to another. What are the systems we are using for that? It means a signal conditioning to be done from low level to high level, some amplification systems from the analog to digital forward to the computer. After processing from the computer to the actuating systems, so such data acquisitions to be done there. How we have done this? So these data conversion devices are very important component of machine control unit. I am calling this as a MCU. For controlling the machine, it means for controlling the actuations. For controlling the actuations, we need some conditioning systems, data transfers, data maintenance, data controls. Then this is to be processed and this will give the information to the actuators. In such way, the actuators is going to work. We know the various actuations of electrical, hydraulic, pneumatic, mechanical actuating systems are there at the exit, at the output. But input we have the various sensors to detect what is happening, what is the set value we are giving. But in the middle, this processing to be takes place by the microprocessor, microcontrollers, PLCs. These are all digitals. How this data conversion takes place from the analog to the digital formats and from the computer to the actuating formats. So that this data conversions are needed to control this machine control units. I am calling this as MCU. MCUs are controlled by various computers. That's it. Various computers or microcontrollers, microprocessors which are accepting signals only in digital form. Which is accepting only in the digital form. But what we are receiving in the analog forms. That is the form which is in the zeros and ones. So maybe these digital forms are in the binary forms or zeros and ones. While the signals received are from the signal conditioning module or sensors are generally in the analog form. The temperature sensors, pressure sensors. So those are in the analog form. This is to be converted. Data conversion to be formed there. Therefore, the system is essential to require to convert. What are the two types then? We have analog signals into the digital form. I am naming these two forms as analog to digital conversions, analog to digital conversion ADC, and digital to analog conversions such as DAC. These two we have to do before and after. Before is analog to digital, which is coming inside, and after is digital to analog again for the actuating, electrical actuatings, mechanical actuatings, hydraulic actuatings. That is to be again analog. So this both ends we have this data conversions. So that is ADC one side, DAC and the other side. Based on the signal received from the sensors, yes, based on the signals received from the sensors, the machine control unit generates actuating signals in the digital form. Most of the actuators are DC servo motors. We have studied the servo motor, which contains a closed loop system which have a feedback. So it can able to accept this analog. It is having the DC servo motor having the capability, but all others are not having. Therefore, the digital signals must be converted into analog form. So that requires the actuators can be operated accordingly. Therefore, after the analog signals are received from the computer, this actuator can be operated accordingly as the set value, as the process value, as the amplified value will be received to this actuator. So it can work. Where it is happening? It is happening in the control center, microprocessor, microcontroller. I have, see, in this diagram you can able to see we have input which is given here. Analog input is given. At the beginning, we have the analog to digital converter at left. And this after conversion, from this temperature converted into volts in a measurable digital form. And then this digital form is given the feedback to the microprocessor, microcontroller, or PLC, whatever it is. So these are the major devices we are using for electronic controlling in the mechatronic system. So now the received signals are working on those datas, what is converted. The temperature is less, temperature is high, to be amplified, to be reduced, noise is high, noise to be reduced, linear, non-linearities, reductions, increasing, all these processes are done, controlling actions are done here. This controlling information to be given to the actuating mechanism, again to recontrol the feedback loop. Then only it will actuate to move forward, reverse the position, the velocity, whatever it is. That is to be analog, that are all analog. Again what I am doing, this digital forwards, this computerized outputs, controlled feedback output to be fed to the system, then it works. So I am feeding here. Feeded. Therefore, this conversion again takes place here, digital to analog converter. This is what? DAC. This is what? ADC. So at both ends, before microprocessor and after microprocessor. Now after conversion, it became again analog. Analog we have received. Again that side analog came. These outputs are given to the actuators. Actuators, drivers, hydraulic systems, pneumatic systems. So likewise we have taken out. This is a part of digital conversion, data acquisition systems we have done. So what it is for these purposes, digital to analog converters are used, abbreviated as DAC. One I have told as ADC, one I am telling as a digital to analog converter. ADC at the front, DAC at the other end. So this is the flow. What I conveyed in this image is, I am mentioning in this format as a flow chart. You see now, a physical system having this actuation process. So from the actuation process, maybe the temperature, maybe the pressure, maybe the velocity, maybe the position, maybe the angle, or physical or analog measurements are taken through sensors. We have done. And this input has been given to the signal conditioning unit. Noise reduction, this band filterings, all things are done. This are analog signals are to be converted as analog to digital conversion, now done. Analog to digital conversion. Now from here we are receiving to the computer, which contains i5 processor, i7 processors, Motorola 8085, this microprocessor, microcontrollers are available here. So this is going to receive the feedback as per the program. It has to amplify or analyze whether to stop, whether to on, whether to increase or decrease. All things are commandable here. Now we have received the program. Which is to be again sent to the actuating mechanism. In such a way the modification will take place there. What happens now? This digital format again to be converted. How? Digital to analog conversion. Here analog to digital conversion, again digital to analog conversion happen. Some noise reductions, maybe millivolts or microvolts into the volt conversions, amplified signals, filterings are done here. After this, we are giving to again this sensor. This sensor gives the information after error detection to the components. It means to the actuators. Actuator is going to operate the system. That is a physical system. This is a world, the working environment, the plant. This is the plant, system plant, where we are going to work. The output takes place in area. So this is a cyclic process. Physical measurement, conversions, operation by the computers, programming, and this programmed signal to be again fed to the physical system again. So the cycle which contains ADC and DAC as a data conversions, data acquisition systems. A PC-based data acquisition systems and control systems are widely used in industrial and laboratory applications. It is a PC-based operations. Here we have computer, PC-based operations. Like monitoring we can do. Just we are seeing what happening. We are observing the data until when it is in control. If it exceeds the control limits, we have given the temperature limit up to 35. If it's exceeding the limit, we have to control. Just we are monitoring first on the computer. Data are received. We are not doing anything. And if it exceeds, I am controlling. Controlling can be done, and that soft data acquisition and automated systems can be done through automatic systems because it is pre-programmed. We can do. Selecting and building a data acquisition and controls system that actually does what you want it to do requires some knowledge of electrical and computer engineering. A mechanical only will not help. At this conversions, we have to combination of integrated approach of electrical along with the integrated approach of computer engineering, ITs, programmings, and conversion signals, noise reductions, filtering, all these things are done. Through the transducers actuators, through signal conditioning devices, through data acquisitions and control hardwares, we want to use this. I have sketched you a simple format here. But it contains all sensors, it contains hardware, it contains signal conditioning device, it contains actuator, it is there. So altogether only it is possible to make one mechatronic system, not individual. So computer systems and softwares. This is integrated approach. A data acquisition system consists of many components. We have understood the concepts of what happening throughout in this diagram. So we have to subdivide those classifications, what it is, the components are. Components that are, see, it is integrated to sensor physical variables through sensors and transducers. Here, this is the one. Sensors and transducers. Condition the electrical signal to make it readable by a analog to digital board computer. Computer will treat only zeros and ones. We know this. Accordingly, we should convert the signals and we should feed. What we need there? We need there the ADC, analog to digital conversions. On the other hand, DAC we needed. Because this actuating systems does not know the binary digits. They know only the action to take place. So convert the signal into digital format, which is acceptable by the computers. And then we have to do that. This computer is going to do the process, analyze, store and display. These all things will be done. To the monitor we can able to see, we can memory we can able to store, process simulations we can do, controlling actions we can modify the data and feedback again. So all things are done through the microprocessors in the computer. Now it is done. We have a sketch of figure how it is happening. One by one we have to see. So here in general the data acquisition system, we have seen what availability are there. Physical system. This physical system which contains a sensor, a transducer to measure first. So physical variables, a temperature, pressure, motion sensors are measured. Temperature, pressure, motion and flow rate. So all are measured here as a physical system. This has to be sensed, and then the sensors and transducers has to have some filtering process, millivolt to voltages, so noise, electrical signals, electrical signal conversions and signal conditioning. This electrical signal conversions after this to be amplified or filtered, those things to be done. Filtering and amplifications are done. After this amplification, computer will know only zeros and ones. So see binary digits. After again this side, similarly we have, before going there, as I told you, analog to digital conversions, A by D conversions. So this works. After A by D, it is converted to the digital form. So now the computer. After computer, what we will have? Again repeats here. Again it is going to repeat here. What happens? We have D by A. We have signal conditioning, and we have again this sensor measuring units to the physical system. It comes here. So likewise, a cycle will be there. One by one we have to. Right. First I have taken on this first physical system is there. From the physical system, we are from the environment, from the world. I am taking the input. I am taken the input through sensors. What are the inputs can be? What are the utilizations we are doing here? Maybe the displacement, maybe the level, maybe the electrical signals, maybe on or off presence, positions, temperatures, pressure, light on off, forces. So various types of sensors or signals we can able to receive. This we have displacement sensors, temperature sensors, level sensors, photoelectric sensors, laser sensors, all pressure sensors we have. LVDTs, strain gauges, all sensors to detect the environmental physical systems, analog systems. Again now we have to convert. A transducer convert at temperature, pressure, level, positions, etc. into a digital format of voltage and current and frequency, or otherwise the pulses and other signals. So these are the digital signals. This is converted to this one. This is converted to the voltage and currents. Convert. An actuator is a device that activates a process control equipment by using a pneumatic, hydraulic and electrical. This is again the output in between this conversion to be operated to the computer. From the computer again it is going where it is actuating mechanisms are four: electrical, hydraulic, pneumatic and mechanical. So that is what? Maybe pneumatic actuation, maybe hydraulic actuation, maybe electrical actuation. Powers. Again that you have to do in between the computer. The valve actuator opens and closes a valve to control a fluid rate. An example I am giving at the outside. This electrical signal again to be converted here. Again to be converted to who? To these concerns to operate this DAC is there. So likewise. So signal conditioning. From the transducers we have received. So at next point, signal conditioning. Where we are here. This two we have seen. This is the displacement sensors, level sensor, position sensor, velocity sensor. Next we are doing here the signal conditioning process. Signal conditioning circuit improves the quality of the signal generated by transducers before they are converted into digital form and by the PC's data acquisitions hardwares. Yes, the signal to be conditioned. For example, I am telling the signal scaling, the amplified, because sensor receives the temperature measured in a very low level. It is not accepted by the computer. The signals given by the computer are not accepted by the CNC machines. Therefore, the relation to be made in terms of electrical. So that the signal conditioning to be made in between the computer and the sensor. Again from the computer to the actuating mechanisms. So this amplifications to be done. Linearizations, filterings, attenuations, excitations, all things are done. The band pitching, which pitch we need, so that the frequency acceptance, frequency rejections, all things are made there. In the signal conditioning equipment. So that is what this signal conditioning we have. So that from the block diagram I have taken this. One of the most common signal conditioning function is amplification. Generally we do this amplification, most amplification and filtering. Filtering, noise reduction. These things are generally we are doing. For maximizing the resolution of the voltage range of input, the signal should be approximately equal to the maximum input range of the analog to digital converters. So what input we receive, that is not matters. What the analog to digital converter receives, for that conversion we should give the input. That level of amplification we need from the sensor, that is not possible. Therefore we are including a signal conditioning device such as amplifiers, such as filters in between the analog to digital conversion and the sensors. So that is what this diagram indicates. From the physical system, from the world, from the present environment, sensors are received. This is having a low voltage, this is having a low current, this is having a low frequency, which is not readable by the analog to digital converter itself. Analog to digital device itself not possible. Then only to the computer. Therefore, I have in the middle a signal conditioning device, which what it does, which is going to amplify and it gives the high. Amplify, the filtering can be done here. Amplifications expands the range of transducers signals so that they match with the, now I have expanded the signal from the low level signal to the high level signal. Now these signals are matching the analog to digital converter signals. So both are matching, then it can feed it to the analog to digital device. That device is convert again this analog signal to the digital. This again computer, again back. So accordingly we can able to do. For example, 10x of amplifier maps of transducer signals which range from 0 to 1 volt, convert this 0 to 1 volt into 10x. 1 into 10 equal to, we will get 10 times of equal to 10 volt we will receive. So we have received 1 volt from the sensor, and this amplifier is doing the job of 10x times, therefore into 10x, so we will receive a final 10 volt. This amplifier is converted. This 10 volt is accepted by the analog to digital converters. So from this conversion we can go for the computers. So signal conditioning, amplification, filtering, linearization, isolation. This is what the point is. It is shown here. This point. So data acquisition systems control the hardware generally to perform one or more of the following functions. What are they? Analog inputs, it's controlling to digital format, and digital to analog. Analog outputs, yes, at both ends, input and output. In between what we have? To the computer. To the computer we have digital input only. And digital output should come. So here the computer, here it receives the digital, gives the digital. It means we can CPU we can put. Right? Before that, here the sensor is there, here the analog is given, and here we are taking the analog output. So in between here we should need, we are here, this is analog to digital conversion, this is digital to analog conversions. So this is the general sketch we can able to understand. So that is what. So timer and the counter functions, analog inputs. How What are the analog inputs we are doing? A number of input channels. How many inputs we can receive? A computer does the comparison object. Computer does the increasing gain functions. So we will have multiple inputs to the program. We will get multiple outputs from the program to the actuations. So how many number of inputs we are giving? That is received by the analog to digital conversions. That is received by the analog inputs. Single-ended or differential input signals. Sampling rate in sample per seconds. Yes. Resolution usually measured in bits of resolutions to be converted. Input ranges specified in the full scale of voltages, millivolt to higher volts. Noise and non-linearity to be filtered, noise to be reduced, pitch to be reduced, what pitch it can accept, what frequency it goes. Those things are all monitored and received as analog inputs. So noise is received. It should be reduced there. Number of inputs are received from the various input channels. Then it's all inputs to be converted and feed it to the computer for the program. That should be done. So these are the inputs received by the analog. How we can do this? You see, input may contain first input, which contains here the amplifier, then the amplifier may contain analog to digital conversions, and this digital conversion is given output to the PC. So that is how this analog input devices will be there. Analog input device, right? So such diagrams are given here. The same I have drawn. So analog to digital converters, input signals are received, sampling rate, resolution at what? What is the range? 10 millivolt to 10 volt. So that is the range. Signals are received in 10 millivolt, and the acceptance level is 10 volt. So signal conditioning and here the amplification to be done. Amplification to be done. So there are some conversions to be carried out. Input signals. I am talking about not only the left side, not only the ADC, but also the DAC also. That is why the analog and the digital. So signal is continuously received, continuously it should change because temperature will vary continuously, pressure will vary continuously, rotation will vary continuously, angle will vary, position will vary. So the received signals are immediately fed to the program, to the microprocessor. Then it understands what's happening in the world, in the environment, and it means the physical systems. Then in continuously it should program, this is what happened, this is what the error, and program to be done, and it should be fed back. So therefore the signals are continuous. Strain gauge of most transducers produces analog signals. So this is one part. A digital signal is either or maybe on or maybe in the off conditions. So the light switches on or off can be done here. So sampling rates determines how often the conversion takes place, and then the highest of sampling rate are to be maintained properly. So these are the conditions we have for the analog signals. So the signals may vary up and down. We have the constant string lines. We have to maintain a constant string lines here. So it may, if the samples are vary for the various inputs, this is the set value. This is the set value. It may increase or it may decrease. Our microprocessor, our program to actuate, to maintain this set value. So this is our work done by the PID controllers. Integral derivative, progressive proportional integral derivative controllers will maintain this. Obviously the overshootings and undershootings to be eliminated, and we need a constant output. So that's how to be done here for the output to be maintained uniform. So some of the devices. And then after conversions, a digital analog outputs to be taken outside For the same analog output also, we will have similarly conversions, amplifications, and then the output will be there. So data acquisition systems does not require any programs. It's just a conversion. Program is on the microprocessor. Enables a developer to design a custom instance instrument best suited for their application. Test points, snap masters, lab view, data zips, some of the softwares are there. Are predetermined softwares which does these actions. So likewise it is possible. So what are these data acquisitions can do? Factors to be considered are, it is a fixed or mobile applications, can be the type of input output signals, a digital or output, digital or analogs, frequency of inputs, resolutions, continuous operations or discontinuous operations. So these are the various data it can able to consider before going for this operations. What type of analog or digital, whether it is what is the frequency, what is the resolutions, what about the overall cost happening, whether it is continuous inputs or continuous outputs required, one time input or it to be cyclic. So those data we need before going for the giving to the input to software input to be given in this mapping systems. So some of the other these things. The summary. In data acquisition systems, we have seen about the signals, sensors, which is converted for signal conditioning, and then analog to digital conversions, then the CPU, that is microprocessor, and then other end again we have digital to analog, and this converted to the signal conditioning again, and from that we are giving to the actuating systems. So this total process is controlled as a data acquisition system, that is data conversions for mission control unit, MCU. The remaining part of the subjects, we'll see you in the next session. Thank you.